Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths Topic Test produced by AQA. This video is Algebra Recap and Review. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Welcome back to another AQA topic test. This one's entitled Algebra Recap and Review. It seems to be mostly to do with the equations of the form y is equal to mx plus c, so equations of straight lines, understanding what m is, c is, and how that relates to the graph of that equation. There's also some things in here about exponential curves, and weirdly something on distance, speed, time. Okay, so that's what most of this paper is about. Okay, let's have a look at the first question. Y is equal to 2x plus 8, and we need to circle the line that is parallel to it. Okay, y equals mx plus c is the general form of a linear function where m is the gradient and c is the y-intercept. And most linear equations should be easily rearrangeable into that form if they're not already in it. Let's have a look at the first one. So if we've got m is the gradient and c is the intercept, we can read that straight out of the first one. So here we can see that m is a half and c is 8. In the second equation, your constant and your term in x are the other way around, but you can probably still see that minus 2 is the gradient and 8 is the y-intercept again. Now this next one isn't quite in the right form, so we need to rearrange it first. If I take this term in minus 2x and move it to the other side of the equation, rewriting it, so we get y is equal to 2x. You should now be able to see quite easily that 2 is the gradient, and the y-intercept, there is nothing following that, so that would imply the intercept is 0. And then finally I've got y is equal to 8 divided by, or 8 minus x divided by 2. I can actually break that into two separate fractions. So 8 minus x over 2 is the same thing as 8 over 2 minus x over 2, which is the same thing as y is equal to 8 divided by 2 is 4. And I can rewrite minus x over 2 as minus a half of x. So again, the gradient of that line is that number there, negative a half, and the intercept is that one there. It's going to be 4. Okay, having rewritten all those three lines in the form y is equal to mx plus c, I can now go and answer the question. Now, two lines that are parallel are going to have the same gradient, aren't they? They're going to have the same change in y with respect to x. Okay, so two lines that are parallel are going to have the same gradient. So here, the line we're given has a gradient of 2. So which other one also has a gradient of 2? It's that one, isn't it? That's got a gradient of 2. Y is equal to 2x. It rearranges into. Okay, now the next question says circle the line that is perpendicular to y is equal to 2x plus 8. Now, when two lines are perpendicular, they cross at right angles. And if one of those graphs has a gradient of m1 and the other one of those graphs has a gradient of m2, then m2 then is going to be the negative reciprocal of m1. Okay, which means you take the gradient that you're given, in this case the 2 from y is equal to 2x plus 8, and you find its negative reciprocal. So reciprocal would be taking your 2 and rewriting it as 1 over 2, and negative reciprocal means putting a minus sign in front of it. So m2, the gradient of our perpendicular line, is going to be minus a half. So we've rearranged each one of these in the first question. Don't know if you noticed they're exactly the same equations as above. So let's have a look above. Which ones had a gradient of negative half? It was that last one, wasn't it? It was that one there. Y, as it rearranges to y is equal to 4 minus a half of x. Okay. And then finally, this last one says circle the line that passes through the origin. And again, I've got the same 4 lines. Now, what we're looking for now is the intercept, then, aren't we? We have 2 lines. So if a line passes through the origin, then its y-intercept, where it passes through the y-axis, is going to be 0, isn't it? So we're looking for a y-intercept of 0. So if you remember, y-intercept is the c value. So coming back to our original 3 equations, we could see in the first equation the y-intercept was 8, in the second one it was 8, in the third one it was 0, and in the last one it was 4. So it's the third equation along that one there. Question 4, work out where the line 2y minus 3x minus 8 is equal to 0 crosses the y-axis. Now again, we've got this as a phrase, crosses the y-axis. Basically what they're asking us here, again, is what the value of c is in the equation y is equal to mx plus c. So we need to find that value of c then. Okay, now we've got the equation 2y minus 3x minus 8 is equal to 0. It doesn't look much like y is equal to mx plus c yet, but with a little bit of rearranging, we should be able to make it more look like that. So we've got minus 3x, so either adding 3x to both sides or using change sides, change signs. We can move that over there. Similarly, the minus 8 can switch to the other side as well. That should give us 2y is equal to 3x plus 8. Okay, so it's looking a bit more like that form now. I've got y equals something to do with x plus something. But I've got 2y here, not 1y. So I'm going to need to divide both sides by 2 to kind of simplify the left-hand side so it's in the right form. So 2y divided by 2 is simply going to give me y. 3x plus 8 over 2. Again, I can break that into 2 separate fractions and say that's 3 over 2x plus 8 divided by 2, which is 4. So here, that value of c is going to be given by that 4 there. Okay, but they want it this time in as a coordinate. Do they want a coordinate? Answer. We've got open bracket, close bracket, comma, open bracket, close bracket. Okay, I think they want a coordinate, but they've just put an extra bracket in for some bizarre reason. So it's going to cross the x-axis or the y-axis at 0, 4 then, isn't it? 0, 4. So that will be 0 and that will be 4. Question 5 says, here is the graph of a straight line, and we're asked to work out the equation of the line. Okay, now to work out the equation of a straight line, you need 2 pieces of information. You either need the gradient plus one coordinate, or you need two coordinates. Because if you've got two coordinates, you can work out the gradient, and then therefore you've got a gradient plus a coordinate. Okay, so they're the two things that you need in order to work the equation of a straight line. Now here we've not been given the gradient, but we have been given a whole bunch of coordinates because we've been given the line itself. So it's a matter of reading off two handy coordinates for ourselves to use in this calculation. So I'm going to use the endpoints, I think. So I've got that point up there. That is the point 0, 6, isn't it? And the other end of the line down here, that is the point 2, 0. Okay, so knowing those 2 points should be enough information in order to work out the equation of this line. So first up, let's work out what the gradient m is. The gradient m is going to be given by changing y. Sometimes we should write this as y2 minus y1 over x2 minus x1, where x1, y1 and x1 and x2, y2 are two coordinates on the line. So let's make this first equation on the left x1, y1, and the one down here x2, y2. Now we can then sub carefully into this equation. y2 then is going to be my second y value, which is 0, minus my y1 value, which was 6 up there, divided by x2, that's my second x value, that's the 2 there, minus my first x value, which was 0. Okay, so that gives me 0 minus 6, which is minus 6, 2 minus 0, which is 2, and minus 6 divided by minus 6 divided by 2 is negative 3 then, isn't it? So then m, the equation of my line, has a gradient of negative 3. Now if you don't like subbing into that formula, you can also just look at the change in y, which is the vertical distance between those 2 points, and then divide it by the horizontal distance. You see the vertical distance is the distance from 6 down to 0. It's minus 6 because it's going down. And then you've got your 2 there, and just divide one by the other. That's the other way of doing it if you don't like the formula. Right, so now I know the gradient, I can say that the equation I'm looking for is of the form y equals minus 3 of x plus c. So we got most of the equation. We know what m is. All we don't know now is c. But actually we have been given c. It's the y-intercept is here. We can read off the graph. It's just 6. Now if we didn't know, we could sub both of the coordinates in and work out what c is, but here I can just sub in 6 straight away. So y is equal to minus 3x plus c. C, the intercept, is equal to 6. So the equation is y is equal to minus 3x plus 6. Question 6. Solve the equation 3x plus 14 is equal to 2. Right, so subtract 14 from both sides, or change sides, change signs to move the 14 to the other side. I'm going to get 3x. Those two things are going to cancel each other out. I'm going to get 3x is equal to 2. Subtract 14, which is minus 12. Then dividing both sides by 3. I'm going to get x is equal to minus 4. X is minus 4. Question 7. Here's the graph of y is equal to 3x minus 1. Yes, it is. Use your graph to find the solution of 3x minus 1 is equal to 0. Okay. Now this is the equation y is equal to 3x minus 1. So if I want 3x minus 1, which is equal to 0, basically I'm asking what the value of x when y is equal to 0. Now the line y is equal to 0 is actually the x-axis, isn't it? All the points along the x-axis have a y value equal to 0. So bringing up my ruler, I'm going to draw a line through y is equal to 0, which is the same thing as the x-axis. So where does that line cross my line y is equal to 0? Well, the point is there, look. That's the point where it crosses. I've got 5 little squares between 0 and 1, so then each one of those squares is going to have to be 0.2 then, isn't it? So 2 squares is 0.4. So I'm going to use the graph, and the graph is going to tell me that x is equal to 0.4. Now if you solve this algebraically, you probably get a slightly different answer, wouldn't you? Moving the 1 to the other side and divide by 3, you get x is equal to a third, which is 0.333. But you're going to get half, you're going to get a little squared either way difference. And actually the mark scheme gives any answers between 0.2 up to 0.4 as being correct. So you get like a half a square tolerance either side of the true answer. Question 8, solve the equation 5x plus 1 is equal to 2 lots of x plus 4. So we want to get all the x's on one side and the numbers on the other. But let's try multiplying out this bracket first. Don't always have to multiply it. Sometimes you can divide by the number on the outside, but here we've got x's on both sides. So I think it's going to help to multiply it out first. So 5x plus 1 is equal to 2 lots of x, which is 2x, plus 2 lots of 4, which is 8. Okay, so you can see that we've got unknowns on both sides here. So let's subtract 2x from both sides. So that will leave me with 3x plus 1 is equal to 8. And we've also got numbers on both sides. So let's subtract 1 from this side and also 1 from here. That's going to give me 3x is equal to 7. And then dividing both sides by 3, I'm going to get x equals 7 over 3. Now 7/3, a top-heavy fraction or improper fraction like that is a perfectly acceptable answer. So you can just leave it in that form there. It's probably the easiest way of doing it. So just leave it like that. Question 9, Amy circles from home to a park and back home again. The graph shows her journey. And we've been given a distance time graph here. What do we need to work out? Amy stopped at the park for 15 minutes. Work out her average speed from home to the park in kilometers per hour. Amy stopped at the park for 15 minutes. Work out her average speed from home to the park in kilometers per hour. Okay, so she stopped for 15 minutes. That's that part there. So that's where she stopped in the park. So that means that her journey to the park was this part, wasn't it? Okay. Now you can see she's gone at 3 different speeds in that as part of that journey, but we just need to know her average speed for that whole part of the journey. So all we need to know is the total distance travelled, which is that distance, divided by the total time taken, which is that amount of time. Okay, so the total distance travelled then is from 0 to 20. It's got 20 kilometers. And the total time travelled, or the total time moving, is 75 minutes. Okay, so what's that in hours then? 75 minutes is 1 hour and 15 minutes, and 15 minutes is a quarter of an hour, isn't it? So it's 1 1/4 hours. So I'm going to rewrite that as 1 1/4, or just 5/4 might be easier to use. Okay, so then work out our average speed. So DST triangle, speed equals, so cover up the thing that you want to find, which is S. And then the other 2 things tell you how to find it. So speed then, average speed, is distance travelled over time taken. In this case, it's going to be 20 kilometers divided by 5/4. So you're dividing by a fraction there, aren't you? So dividing by a fraction is the same thing as multiplying by that fraction flipped over. So I can change that to 4/5 of 20. That also works. So 20 divided by 5 is 4 times 4 is 16. So that's 16 kilometers per hour. So using fractions like that, I didn't have to use a calculator in the end. It worked out quite nicely. Question 10a, plot the graph of y is equal to 8 times 2 to the power of x for values of x from -3 to 3. First of all, we need to complete that table of values, don't we? So equations of this form are what we call exponential graphs because the x, the variable, is the exponent or power in the equation. Okay, that's why it's called an exponential graph. And they have a very distinctive shape. They look like this, which you should know about already. Okay, so you should already know what this graph is going to look like before you draw it. It's one of the sorts of graphs that you, oops, I should have really done it on the page. It's one of the sort of graphs that you need to remember their basic shape, and it will help you in these sorts of questions. Okay, so it's an exponential graph. That's what it's called. Because the x is the exponent or power in this equation. Okay, so we've got some of the values given. We need to work out the others. Y is equal to 8 times 2 to the power of x. So when x was 3, 8 times 2 to the power of x would have been 8 times 2 cubed. 2 cubed is 8. 8 times 8 is 64. Okay, so for this next one in here, I'm going to get y is equal to 8 times 2 squared, aren't I? So 2 squared is 4. 4 8s are 36. Okay, what about in this one here then? X is 1, so y is equal to 8 times 2 to the power of 1. 2 to the power of 1 is 2. 2 times 8 is 16. Okay, I've been given that one. So when x is -1, what then? So if y is equal then to 8 times 2 to the -1, 2 to the -1. Negative indices mean 1 over, or the reciprocal of, don't they? Okay, so that is the same thing as 8 times a half. 8 times a half is 4. This next one here, it's going to be y is equal to 8 times 2 to the -2. Again, we've got a negative power. So that is the same thing as 1 over 2 raised to the positive version of that power. In other words, 1 over 2 squared, or 1 over 4, a quarter. So 8 times a quarter is 2. Okay, so notice everything is positive, just the same as what I was expecting. Remember, I knew the graph looked like this. There aren't any negative values in an exponential curve. They're always positive. Okay, so let's plot these points on then. So when x is -3, y is 1. So just checking the scale on my graph here, I've got one little square, it being 2 units. So x equals 1 then is going to be kind of that point halfway between 0 and 2 then, isn't it? Okay, so it's just, we'll just draw a little dot and put a circle around it so it's easy to find. Next one, when x is -2, y is 2. That should be slightly easier to plot. Okay, so that's that point there. Next one, -1, 4. -1, 4 is there. And then I've got 0, 8. 0, 8 is there. 116. 116 is there. 236. Which is there. And then finally 364 up there. Okay, so once I've drawn all my points, I can then join them up with a nice smooth curve. Try and go through the center of each of the points that you've drawn. If you miss, you can get marked down. So I'm going to do those 2 bits again because I missed. Okay, it doesn't start and stop with your endpoint. I know that kind of continues. Okay, so that's my graph then. And again, I kind of knew what it looked like already. There was my sketch of what it was going to look like. Here's my graph. It's pretty much the same graph. So I'm confident I've done that one right. Right, it says explain what happens to the value of y when x is a very large negative number. Okay, so when x is a very large negative number, it's numbers heading off in this direction. Now you can see that the graph is getting closer and closer and closer to 0, but it never actually touches. We call this line that the graph is approaching to this line here. In this case, this is what we call an asymptote. I don't think you need to know this word for GCSE, but it's something you need to be familiar with and talk about at A level in a bit more detail. So you don't really need to know that word for GCSE, but it's a useful one to remember if you're thinking about carrying on with maths next year at A level. And you can see our graph line is coming closer and closer and closer to that asymptote, but never quite touching them. We say that it tends towards it, but it never actually reaches it. So the language you use, it says that it tends towards whatever that value is. So explain what happens when the value of y when x is a very, very large negative number. We would say that y tends to 0. Okay, so it gets closer and closer and closer to 0, but never actually touches it. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.